All right, let's dive right into this explainer. Today, we're looking at a genuinely fascinating fix to a problem that's been driving AI engineers absolutely crazy for years. If you work in the AI space, you already know that translating natural language into executable database queries, text to SQL, is one of those massive, deeply frustrating bottlenecks. Well, today, we're unpacking a huge leap forward in this space. It's called EXPO-SQL. So, if you're out there building or fine-tuning models for database generation, you've probably hit that exact wall. Your model keeps making the exact same structural mistakes over and over again. You scale up, you throw more data at it, but the moment you introduce a complex query, the model just completely trips up. And you know what? It turns out the problem isn't actually your data or your model size. It's the noise, specifically the noise in how you're rewarding it during training. You see, current reinforcement learning methods have a massive, fatal flaw. They assign a uniform query-level reward. Think about what that actually means in practice. Let's say you've got this massive, beautiful, complex SQL statement. The model gets almost everything right, but bam, it misses one tiny piece of syntax. Under the standard approach, that nearly perfect statement gets the exact same negative penalty as a query that is just total garbage. You're literally treating a 90% correct query as a 100% complete failure. No wonder the models get confused. So here's our roadmap for today's explainer. 1. The text-to-SQL problem. 2. Flaws of query-level rewards. 3. The EXPO-SQL solution. 4. Incremental clause execution. And 5. Upgrading your training loop. Okay, kicking things off with Section 1, the text-to-SQL problem. In a standard pipeline, as we know, we take natural language prompts, use LLMs to map them to SQL syntax, and then execute those queries against a target database. From there, we take that execution feedback, whether it passed or completely crashed, and feed it back into our LLMs using reinforcement learning. But, as we'll see in just a second, the standard way we structure these execution rewards is simply way too coarse to handle complex generation. Which brings us to Section 2, flaws of query-level rewards. When you're training LLMs on these tasks, your reward function is everything. It completely dictates how the model explores the solution space. Query-level rewards, which are uniform and basically just binary pass-fail, force the model into this blind trial and error loop. Because the feedback is uniform across the entire query, your policy gradients become incredibly noisy. The model literally cannot figure out which exact clause broke the execution. But clause-level supervision? That flips the script entirely by giving granular, continuous feedback, which creates beautifully precise gradients. Honestly, think of query-level rewards like that dreaded group project we all had in school. One slacker student ruins the grade for all the perfectly valid work right next to them. It totally dilutes the learning signal. It causes an overpenalization of valid syntax, leading to slower convergence and, frankly, terrible performance on complex queries. The model just can't distinguish between the brilliant parts it generated and that single faulty component. And this is exactly why we needed a paradigm shift. Which brings us to Section 3, the EXPO-SQL solution. EXPO-SQL, or Execution-Based Clause-Level Policy Optimization for Text-to-SQL, fixes this exact bottleneck. Instead of slamming the model with a uniform penalty, EXPO-SQL isolates individual clauses within the generated SQL. It evaluates their specific execution outcomes and then applies targeted rewards only to the faulty components. It completely stops treating the SQL statement as one massive, monolithic pass-or-fail unit. The absolute crucial takeaway here is that EXPO-SQL, quote, replaces the binary pass-fail metric with a continuous, clause-specific reward distribution, unquote. So in practice, if your model writes a flawless select statement, it actually gets rewarded for it. Only the specific logic break in a different clause triggers a targeted policy adjustment. This is a massive, massive leap forward for training efficiency. So how does it actually work under the hood? Let's move to Section 4, incremental clause execution. How does the system actually figure out which clause is the bad actor? Well, the architecture maps the prompt to SQL, sure, but then it runs those clauses incrementally and sequentially, one by one. It checks the execution validity at each step. When the database throws an error, the framework intercepts the results, parses the error messages, and applies those beautifully targeted policy adjustments. Let's look at a concrete example of this in action, because it's pretty slick. If your incremental execution hits a join clause and throws a foreign key violation, the system flags that specific join clause. But, and here's the magic, it suppresses the penalty for the select or from clauses that came right before it. This is huge. It means your model actually gets credit for what it did right, It learns to construct valid SQL incrementally, piece by piece, rather than just blind guessing the entire statement at once. Of course, to make this work, the error parsing has to be incredibly smart. The system extracts very specific issues. We're talking syntax violations, type mismatches, undefined references, and maps them directly to the corresponding SQL tokens. What EXPO-SQL is essentially doing here is taking raw, messy execution logs from a database and transforming them into highly structured token-level reward signals for the LLM. It's brilliant. Okay, so this all sounds great in theory, but how do we actually use it? That brings us to section 5, upgrading your training loop. If you're out there building or fine-tuning these pipelines, shifting to clause-level rewards is an exciting engineering challenge you can literally tackle today. Step 1, replace your uniform feedback with clause isolation logic. Step 2, map those database error strings against known SQL codes, assigning rewards based on severity to specific components like select, join, or where. And step 3, you always want to validate the new reward function against your existing supervised fine-tuning or SFT baseline before you go scaling up to full RL fine-tuning. Now, a key technical requirement to pull this off is implementing a clause splitter. This tokenizes the generated SQL into logical units before execution. By storing those incremental execution results, you build up a per-clause reward history. And this history? It is an absolute goldmine. You use it to compute highly accurate policy gradients during your RL update step. That is the exact mechanism that allows the model to converge so much faster and totally outperform standard prompting strategies. And honestly, the best part is that the codebase is already structured to integrate into existing RL training workflows. You don't need a complete architecture rewrite. You can just focus on the reward shaping layer first. You can grab the full implementation, including the exact execution parsing logic and those clause isolation utilities we talked about, directly from their GitHub repository. And if you want the heavy math, you can dive into the full formulation and benchmark configs in the archive paper. Which brings us to the end of our deep dive. You know, this transition from query level to clause level supervision isn't just a clever trick. It is a fundamental shift in how we teach models to write code. Think about it. If this granular, targeted supervision unlocks the bottleneck for Text-to-SQL, what other complex AI pipelines could be totally revolutionized by moving away from coarse binary feedback? The possibilities for agentic planning and code generation are absolutely massive. It definitely makes you wonder, what bottleneck are we going to break through next? Thanks for joining me on this explainer. I'll catch you in the next one.